Welcome to the first of two RTGWG sessions here in Singapore. I'm one of your chairs, Chris Bowers, and we also have our secretary, Yin Chu. So this will probably be the first time this week that you're seeing the Noel statement related to what constitutes a contribution in the IETF. Please take some time at some point if you haven't already to look at it, and also this actually gets updated, got updated fairly recently, so it would be a good idea to take a look at it again if you haven't. So with respect to IPR disclosure, the IETF has a policy which is described in RFC 8179, which is actually fairly recently updated. And it's also described on the wiki page there at the link. We in RTGWG have been following a specific process to help this process along. So we require that document authors and contributors state whether or not they're aware of any IPR relevant to the document in question. And we do this at the two main gates in the working group document process, at least the main gates with respect to the working group. We do it before the working group adopts an individual draft, and we also do it before the working group requests publication of the document by the IESG, commonly known as working group last call. So a few administrative tasks, and I hope the blue sheets are circulating at this point, because that's one of the administrative tasks we need to take care of. Please sign the blue sheets because they determine what size of a room we get next time. If not enough people sign them, then we can be crammed into a smaller. Obviously, don't have that problem this time, but it can swing both ways. So I want to thank the note takers for this meeting. Our secretary, Yin Chu, and Ignace Bodanis are both taking notes to contribute to the minutes. We are looking for a Jabber scribe. I should be logged into the room. I haven't checked yet, so I can do that. But if someone would volunteer, Adrian Farrell has kindly volunteered. Thank you, Adrian. And then we're going to review the agenda and go through the working group document status, the latest update on that. And we also have remote participants via VFO, and so we'll be stopping to jump in, when appropriate. So as I said, we have two sessions, one today and also one on Thursday. And I'm not going to repeat this agenda, but we're mainly covering the sort of more core items for RTGWG in this session. And then on the Thursday session, some of the more of the role of this working group as a possible intake area for talking about potential new work in the routing area. And this agenda is subject to change. We're probably going to move a few things around for the Thursday time slot. So look at the version that's actually posted. Oh, also, there is a off occurring on Wednesday during the morning session, focusing on data center routing. A lot of the discussion about data center routing had taken place within RTGWG. It's now getting its own off, say at this point a non-working group forming off, and the discussion related to that and the agenda and so on can be found at the links shown here. So you should join that mailing list if you are not already on it. So now I'm moving on to the documents that have been part of the working group. These documents already passed working group last call and were sent to the IESG for publication. The microloop delay draft and the routing types draft. And they're basically ready to be published. The Yang models for RIP and BRRP are also, I believe they made it through the IESG. They had some modifications to be NMDA compatible. That is making them compatible with the new data store architecture. So that took a lot of, took some work to modify them, but thanks to the authors for being tolerant of those changes. So these documents are in working group last call. They basically completed working group last call. And they also had changes as well. So anyways, I need to discuss it with Jeff, but we'll probably be, sending out an email soon, acknowledging that there's consensus to pass those on to the IESG for publication. There wasn't a lot of vocal support, but I think given that this was a design team that was, housed in the working group, and they're doing sort of thankless work, and it's part of a general project for the IETF to publish Yang models for IETF technology. I don't think there's a whole lot of debate over whether or not there's consensus to adopt them, and no one objected. So I think we're adopting them, or not adopting them, but passing them on to IESG for publication. There are a couple of documents that are existing working group documents. The microloop problem statement document, BGP PIC, and two other documents that sort of I grouped together, the desk source routing document and the enterprise PA multi-homing document. There was some discussion after Prague related to kind of bringing these into alignment. There's some changes in the PA multi-homing document to clarify and actually make the two descriptions of the routing agree. And I think Jen's going to talk about that in more detail. Other working group documents, the multi-homed prefix LFA document. Jeff and I are both co-authors of that document, so we will not be conducting the working group last call for that, but Yingzhen Chu will be. In the case of the RTGWG backoff algorithm, I'm a co-author of that, so Jeff will be conducting that one, and he'll be doing it soon, I believe. Not that I'm pressuring you or anything, but that was what you told me before. And there was a document that has started, I think work started on it 2 years ago or more, and it actually reached a pretty good state pretty quickly. The encapsulation design team recommendation document, and it expired, but it's probably still a good thing to get it published. The last status was that it needed more details on MPLS encapsulation. I had a conversation with Stuart Bryant yesterday, and he should be contributing to that and getting that kind of wrapped up. Recently adopted working group document is the routing timer parameter sync document as well. So that's all I have for the review of the current status of documents. If you have any questions, we'd be happy to take them. Otherwise, Greg Mirsky is up first, so Greg should come up here and If anyone has any questions, we can take them while we do the transition.
Okay. There have been some unclarity with regards to IPR, so if you could provide short history, what happened last 6 months, would be great.
Yes. This is update on a proposal that was presented, I think, like 2 or 3 meetings back. I don't see the prompt. We don't see anything. I think 1-1. Yes, it's working. Okay. I guess I'm guinea pig.
So do we have an AV person accessible? Because we've just had a bit of an AV problem here.
Actually, if that's a problem, I can just talk without video because it's
At this point,
very straightforward.
Wait, no.
Okay, so we have
No,
some
that's
back.
back to that.
Okay, let's hope that everything else will come back. Okay, anyways, at any rate. This work was presented, and it's to propose use of BFD in a multi-point networks, often referred as point-to-multipoint environment, to fast detection of master VRRP router failure and faster switchover in VRRP. Yes, VRRP-v3 allows for sub-second intervals, but it seems to be redundant and unnecessary if we have BFD that can do and provide the failure detection. And at the same time, so the scenario how and what is being monitored in VRRP fits nicely with the BFD multi-point networks specification, which is unidirectional because it uses demand mode, and that fits that backup VRRP router monitors the well-being of the master. So again, it's a unidirectional environment. In the original proposal, we propose to use just out-of-box BFD with the, oh, excellent. We have it back. So we propose to use specification BFD for multi-point networks, and there was an IPR associated with it, and there was some concern. So authors went back and thought of, okay, how we can improve and at the same time create a differentiator with existing IPR. And so here is the proposal, so that we can use VRP control messages to advertise BFD discriminator of the master. Because unlike in point-to-point BFD, where there is a three-way handshake to exchange discriminators between peers, in multi-point BFD, there is no handshake because it uses demand mode from the beginning. So thus, the remote peer, the tail of point-to-multi-point BFD session, has to do demultiplexing not on your discriminator in a control packet, which is locally unique for the receiver, but on remote my discriminator, source of the message, and source address of the message. So by providing information in VRP control message, we enable auto-discovery of existing BFD environment. So if some backup router comes later, it doesn't have to be explicitly provisioned either through configuration or a control plane. So VRP control message does that for us automatically. And that introduction, so that change, we believe, offers belief that creates sufficient divergence from existing IPR, so then there is a way of implementing this without really discussing the IPR. So in red that you see that our proposal to extend VRP control message by adding optional master discriminator information that will be received by the backup router, and so that can help to do demultiplexing. And that because that included in each and every control message that's sent by the master. So at any time we have a new backup, it can join and start monitoring the well-being of the master almost instantaneously. That text explains the mechanics, and red is what's been introduced in the current version. So that's an update. Next steps, we appreciate your reviews, comments, questions, suggestions, and we just wonder if working group will consider adoption, because now we are not really changing anything in BFD, and all the change is in VRP protocol. So probably VRP protocol now belongs in RTGWG. Or if it's not the case, then appreciate your suggestion where to anchor this work. That's all.
So it would be good to get some more clarification on the IPR issue and because I was
yes.
Maybe we should just discuss it afterwards to make sure that we
okay. IPR is, again, I cannot give authoritative opinion. It's my personal opinion that with this change, there is a sufficient way of implementing this solution without affecting existing IPR.
Okay. I suppose we should look at the guidelines then, if that removes the need to disclose it to do a disclosure, because I'm not positive about those rules, but I don't think so. So but we need to look at whether or not that means
of course,
we still don't need to disclose it. I think you know, one's always very careful when discussing IPR, but I think the rules are the working group can take that into consideration, but it still needs to be disclosed so that the working group can decide whether or not the workaround is acceptable.
Okay, to best of my knowledge, the original disclosure was done timely and promptly. and I can try to reach to their IPR holder to do some consideration, but I don't think that they are capable of withdrawing their IPR to the latest version.
So I think the IPR was disclosed for draft NITISH, right?
No. Originally, okay, so historically, yes, thank you for pointing. We had this draft, and there was another draft with a different proposal to use DFD point-to-point. Then we merged. Some concerns and questions about IPR was raised, and this proposal was removed from the current version of draft NITISH.
Right, but the IPR disclosure that occurred was for draft NITISH, I believe, and
no,
not
from
for
draft Mirsky.
draft Mirsky for this draft.
Yes.
So it's still,
It should be there.
okay, we'll take this offline.
Okay.
In terms of putting it up for working group adoption, we should get this ironed out before we do that.
Okay, very good, thank you.
Thank you. Good morning, everyone. My name is Ankur Dubey. I work with VMware. And today I'm going to talk about using BFD to achieve active standby redundancy when there are multiple set of services running. Some set of services are in revertive mode, while some set of services could be in non-revertive mode. So let's see what that means. Let's straight jump into the use case. So as you can see here, there's the diagram is showing 3 nodes over there. Each node is having a BFD session with the other node, and the control and the network controller is provisioning a set of services. These are L2, L3, or L4 through L7 services. Again, some services could be in revertive mode, which means that if the assigned primary, the preferred node, if that is up, then that is going to serve as the active. While some services could be in non-revertive mode, which means that when a failover happens, after that, if the previous active comes back up, it's not going to claim the active status. Essentially, what we are trying to do is that if a certain node, when it goes down, the other node, which is taking over the non-revertive service, it needs to indicate the node that it went down, that I was alive, and I have taken over the non-revertive services. So that's sort of the requirement there. Some of the details regarding how we can do this is in the next slide. So essentially, what we are proposing is it's a 2-step solution that we're proposing. One is to simply use a DIAC code, which is used by the node, that went up. For example, in this diagram, if node 2 went down, the node 1 is going to set the DIAC code to say I outlived you, and it's going to set that DIAC code in the BFD session between node 1 and node 2. So node 2, when it comes back, it's going to know that, okay, node 1 has taken over me, so I should not claim for the non-derivative services. The node 1 will be acting as the active. So that's part 1 of the solution. The part 2 is if you have a bunch of services where some are non-revertive and some are revertive, you probably want to do granular level failover, which means that certain services on node 1 could be active, which are non-revertive, but certain services on node 2 could be active, which are non-revertive. So how do we do that is basically the controller. It's going to set is going to create a unique bitmap, in which every bit is identifying a unique service, and the same bitmap is pushed to all the nodes. So the node that is setting the diag code can also use a bitmap, and it will set those bit positions which will identify the services that are running as active on that node. So by doing this, you can achieve the active. You can tell the peer node that which set of services are active on me. So essentially, that's that's the two-step solution essentially. Next is we are seeking comments on any suggestions or any comments that you may have in this regard.
So, general comment, I think would have been really useful if you would have included more details about the solution in the presentation. So
The services?
Yeah, so there is text, but it's difficult to do, unless you have read the draft, it's difficult to derive how this really works. Just for next time.
Oh, sure.
Second comment, you definitely need to include BFD working group, and perhaps they're the right place to do this work.
Sure.
Thank you.
All right, thank you.
Now we have Jen Linkova.
Morning. So it's a quick update on enterprise multi-homing draft. Just a quick refresh in case you have forgotten what's all about. We're trying to solve problem of enterprises network using PA address space from multiple providers without using this horrible technology called NAT. And the main problem is there how to send the packet to the right uplink, because providers might do the good thing and implement BCP38. So there are two parts of it, is how to send packet to the right uplink, which is perfectly in scope for routing group. And the solution is to use source address dependent routing when next hop is chosen based not on just on the destination, as in traditional networks, but also based on the source address. And then there is a second part of solution, which is more related to IPv6 stack on host and stateless auto configuration, which I'm not going to talk about because there is no changes there. So the main change, which is the only change made since 0.1 version, is that David Lamparter brought to attention the fact that if we have two routers, which one of them is implementing source address dependent routing, and another one is using destination source routing, then we might see routing loops in some cases. And it's related to the fact how SADR router populates forwarding tables. So let's look at the example topology. Let's say we have router B, which implements SADR, and it has two scoped forwarding tables and one unscoped forwarding tables for everything. And let's say it advertised two scoped prefixes to router A and received an unscoped default from router A. So far, so good. Then the old text, it was the last step of how SADR router populates forwarding table. Basically what we do, we take prefixes from unscoped table, and if those prefixes do not exist in scoped forwarding table, we put them there. So basically make those tables consistent. So for example, in the above mentioned scenario, let's say router B has two scoped forwarding tables, one scoped for blue prefix, one for green. And please note that in this case, those prefixes actually overlap. Blue prefix is more specific to red one. It's exactly a scenario when we can see some interesting side effects. Then blue routing table will have one route scope to blue prefix, red one also has a one route, and then we populate both forwarding tables with default, which is coming from unscoped forwarding table because we do not have defaults initially in those scoped forwarding tables. It all looks good so far, but then what's happening? Because blue and red prefix, because blue prefix is actually more specific in relation to red one, but blue forwarding table doesn't have any next hop for less specific prefix. If router A receives a packet which is has a destination in the blue prefix, and source is also in scope of the blue forwarding table, it obviously will send it to router B. Okay, but then when router B receives the packet, it looks in the scope, and scope is, and based on the packet source, it looks in the blue forwarding table, but blue forwarding table has no route for the destination, so it will use default and send it back instead of using any routes from red table, which would be a reasonable thing to do. So we get a routing loop here. So the proposed solution is we make the last step of populating scoped forwarding tables more generic, because basically unscoped forwarding table could be considered as a scoped for 0/0 for any routes. So what we do, so instead of just populating scoped forwarding tables from unscoped, we kind of going from less specific prefix to more specific and populate tables one after another. So the main change would be, first, we look in the unscoped forwarding table and adding default to red table, but then we also look in the red forwarding table and find there is a entry for /32, which do not exist in blue table, so we populate blue table there. And now we have a forwarding entry in blue table, which allow us to route packets to the red destination. And in this scenario, forwarding routing loops do not exist anymore, so we have consistent behavior between source destination and SADR. So it's a main change, but I think it's quite important because it's changed the way we populate forwarding tables. So questions, comments?
Do you feel there's a need to solicit comments in 6ops and other relevant working groups for the change?
No, I think this is purely related to router behavior in terms of populating forwarding tables. So I would expect more comments coming from routing group, right? Because we do not change anything which is actually in scope for v6ops. Indeed, all comments are welcome, but I expect more people who might be interested in this change in this room and this mailing list.
So please do so. Please ask for comments. It's a good document, it's good shape, and there's no reason for it to sit much longer in the queue. So
yeah, so I posted in the mailing list like on 29th of October, but yeah, probably people filter emails too aggressively. So any comments appreciated, and like we can discuss it in London.
great, thank you. Susan?
Hello everyone, this is Shu Junhu from China Mobile. Today I want to introduce something about the serial separation BNG protocol. This topic is relative to two new drafts. One is the COSP requirements, and another is the serial separation BNG deployment. Okay. At first, there are some basic principles and backgrounds need to be introduced. Like what is the serial separation BNG and why we need the serial separation BNG? Well, as you know, with the rapid development of new services, such as 4K, LTE, the number of broadband service subscribers increased by 10 times. It also causes a lot of challenges for traditional BNG. The most serious issues we confront are uneven resource usage and complex management. As shown in the left figure, the traditional BNG acts as a gateway for user access authentication and an IP network's layer 3 edge. It tightly coupled the control plane with the user plane. Since lack of the overall view of resources and the user's information, the traditional BNG may cause uneven resource usage, especially cause the uneven session or IP address distribution and uneven physical bandwidth usage. Another problem is the traditional BNG is difficult to manage and maintain. Due to the large number of traditional BNGs, we must configure each device one by one at a time. During deploying a global service policy, obviously, it brings difficult management and maintenance. And it also means that any new service has to heavily rely on the multiple BNG devices which should be updated or synchronized. This results in long service TTM. To solve these problems, we proposed the serial separation BNG protocol, architecture and protocol. Briefly, the serial separation BNG is made up of a centralized cloud-based CP and a set of high-performance distributed UPs. The CP is the user control and management component, which supports to manage UP's resources such as user entries and IP addresses. The centralized control plane can provide the capability of unified managing the UP resources. It has the overall view of resources and can distribute the resources as required. Obviously, it can significantly improve the network resource utilization. And since the centralized control plane can provide the unified management interface to the outside system, such as the radio server, the DSCP server, the EMS, etc. It can simplify the management. And because the control plane and the user plane can extend it separately according to different situations, it can also help to shorten the time to market. Okay, what we want to do in IETF, The architecture of serial separation BNG already got accepted by BBF's WT384. And in IETF, we also proposed a set of drafts to standardize the serial separation BNG interfaces. There are three interfaces between the CP and the UP. That is the service interface, the control interface, and the management interface. The service interface is used to pass the PPOE, IPOE dial-up package between the CP and the UP. The management interface is used in sending static configurations from CP to UP. And the control interface is used for deliver user forwarding entries from CP to UP and reporting the user statistic information from UP to CP. And we have some ideas about the service interface and the management interface, and we have proposed the two drafts about them. One is in the NV03 and another is in the RTGWG. We also have a document to introduce the information model for the control interface. However, there isn't a standard protocol to introduce the attributes which described in the information model document. To fill this void, we set up a DLI team, CUSP DLI team, to prepare the CUSP protocol. As so far, the DLI team includes China Mobile, Telefonica, DT, Huawei, ZTE, and S3C, etc. Our work methods. Okay, we work together and will meet every 2 weeks to discuss and design the CUSP protocol. And the progress will be published in the IETF mailing list on time. And the important issue can be proposed in the mailing list for discussion. Finally, a GitHub page will be used to solicit more comments and inputs. The DLI team and the relative works are open and welcome more people who are interested in this topic to join us to contribute your idea and your talent. Welcome. Currently, our DLI team has presented some early research about the requirements of CUSP. The CUSP requirements include version negotiation capability report, CP primary backup capability, the CP's capability to send the user's information table to UPs, and event notification, reliability, secure communication. These 2 pages briefly illustrated. If you have interest in, please review the document and provide your important feedback. And please review our another draft, that is the CUSP deployment. And any suggestions, questions, comments, and inputs are all welcome. At last, welcome new member to join us. Thank you. Thank you very much.
Any questions? Could you please go to slide 5? No, this one. So the service interface uses VXLAN GP encapsulation. And VO3 had long discussion about encapsulation. I believe Genevieve has been chosen as the primary one. Do you see this could work with Geneve instead, or is there a particular reason to use Wix on GP?
The interfaces, I think the interfaces between the CP and the UPs are very complex. So we set up the design team to solve this problem. And other standard have the different architecture or and other different architecture from our COSP protocol.
So do you expect reconciliation at some point in time? Ideally, we would like to come up with single architecture that could address all the issues. Perhaps we could take it offline. We could take it offline if you wish.
Yes.
Thank you.
Thank you.
Luberger? Lu and Dean? Your turn. So before they start, it's not always obvious how to use young models to form a service. So as chairs of routing working group, we think it's really important to help you to understand how to build this service. So it's not only an abstracted service or device model. How do you put this together? How do you make them work from OSS BSS level up to working device? So this presentation is going to talk about it. We will be conducting more research and more presentations on usability of data modeling. Not only on data models themselves, but how to do them.
Well, while the slides are coming up, good morning. I'm actually presenting this. Okay, can you hear me? Great. Can't move too far here. That's going to be odd. I'm actually presenting for AC. His plane was delayed, so he won't be here until this evening. Plan was for him to present and then Dan to follow. What I'm presenting here is first an update, and then we're going to go a little bit into usage of the LNE model. In the past, we focused on NI. The work that I'm presenting is of the routing area Yang architecture design team. I think I got the right name. Yeah, good. Thanks for the cues. And we have a whole slew of people on the design team. The ones in bold are the ones that are sort of active now, but different people have been active over a different time. Where we are is we've done work in different areas. I'm going to talk about each of these before we go into the example. One of the important things to note here is that last bullet. We think we've done the heavy lifting that we were chartered to do. And so we are targeting sort of shutting ourselves down with the AD's concurrence before the next meeting. If you think there's a piece of work that we really should be paying attention to, bring it up on the list, like the working group list, so that we can figure out whether we do it or it's just done in the working group. So first document. We have, which one is this? Okay. So as I mentioned, we have a bunch of documents. One of the important things that we wanted to accomplish was to have a common set of types so that we didn't in each of our models redefine the same things. That work has progressed well. It's now in the editor queue. And I don't have much more to say on that. As I said, these are AC slides I'm going over here. The next one that we're in good shape on is the logical network elements. This document is dependent on some work that's been going on in NetMod. That's also gone through last call. That's schema mount. And the version that we've most recently published really had some minimal changes. After last call, we noted that the shepherd asked for a change. Oh, we identified one change. There was just something missing. It was in the body, but not in the appendix, so we're going to copy it into the body. We've already made that change on GitHub. If you watch what we're doing on GitHub, the other change that's been requested is to be NMDA, to show an NMDA compliant model for LNE. One of the things that we intentionally wanted to make sure that we supported was non-NMDA implementations. Why do we care about that? There's been so much talk about op state and solutions and NMDA. Yeah, that's important, but we also have things that are being built today in the field that don't have all the support for NMDA. So we wanted to work both for non-NMDA and NMDA. So we can add another example if the shepherd wants. And so we have both an NMDA and non-NMDA, but I think it's important that we not lose the non-NMDA one. I'll look to the shepherd who's sitting right there. Do you want both? Do you think, and actually the whole work group, do we want both examples or just the non-NMDA? Loaded question to see if people are paying attention.
The example in appendix right now only have the non-NMDA version. So maybe if you can add the NMDA version, that will be even better.
Great.
So we'll help both
So,
of them.
Expected answer, we're going to have, we should have both versions, NMDA and non-NMDA examples. We'll do that. And once that's done, we think we'll be ready for the shepherd to submit for publication request. So that was LNE. We also have the NI document. Turns out it's basically in the same state. Everything that I just said for LNE applies also for NI. Oh, good. So what else do we have going on in terms of documents? I'm going to actually take the second one first. Early on, we were looking at how to represent a whole device. That's a routing device. In Yang, you have a bunch of what's called top-level modules. So there's no relationship between these managed objects, basically. We thought it would be good to try to show a relationship of those on something that you'd see on a router. And we got a bit of pushback about trying to come up with a formal organization. And in the end, I think we, the design team, all agreed that that pushback was actually valid. But what it meant is that we took a document that we thought was going to be really important and said, hey, this is just informational. And it's not clear how important this construct is to be able to identify routing protocols as routing protocols, other control plane protocols as control plane, management protocols as management protocols. And we sort of let that draft sit around because we didn't have a good mechanism to represent it. Chris came up with the idea. Chris came up with the idea is, hey, we should just use like hashtags to model the different, to represent the function of the different modules. And more than that, we should give the user control of it. So while we may define what we think the sort of attribute of a model is, and a vendor may think something else, it's actually the user, and Chris represents a user, he's at a provider. The user should have control, and he came up with the hashtag, and that's the first draft that's listed here. So in order to support sort of this device organization, we now have this new mechanism that's running through the process in netmod and hashtags. So we have that first document, it's going through the process. We're now back to the device model. What do we do with this? If hashtag gets accepted as a working group document in netmod and it progresses, we think we could do something with it. But we also think this is just informational, not so important right now. We're just letting it sit there, see what develops with tags. If tags go through, they get accepted, they progress, we'll revisit the device model. By the way, we don't have to know the answer before the next meeting. The authors can still work on it, even if the design team's not around. One of the topics that we spent a lot of time on, but didn't author any documents on, was NMDA. So we've been tracking those, contributing, making sure that the work that's going on there will line up with with the area. That's happened. We're still watching what's going on, making sure now the protocol documents support that. But more importantly, we're also looking at the documents produced in the area and making sure that those RFCs line up well. Well, it turns out we really only have one, routing config. And it also turns out it wasn't produced by this working group. It was produced in another working group. But we still have the right people in the room who care about this. So we made sure that work was taking place of updating that. And we have it RFC 8022 BIS now in the NetMod working group. AC is co-author on that. Zen is also. And there was some nice discussion on how we handle Yang revisions. Turns out Yang doing versions and obsoleting old versions is something that still we haven't really figured out as an organization, and that's going to be a hot topic in NetMod. We do think that that's something that this group should pay a little attention to. So, excuse me. The other documents that we've been involved with and have really been outgrowths of the design team work, but haven't been driven formally by the design team, include schema mount. We know that's the new mechanism to allow Yang models to mount another Yang models. So a Yang model, excuse me. So that if you have a module that needs to repeat the same information from another module, you don't have to now just relist the whole thing. You can just say, go use it, import it right here. We also recognize that there was some differences in how we represent trees, how we document Yang models. So we spent a little time there to clean that up, and that is now a document in NetMod on that. And what else is left? The big thing that we have from the original list when we were being chartered, when we were talking about what problems we thought were important to solve for the area, the only one that we really have left is the revision problem. And in particular, in Yang, you have a way of updating a Yang module, but only when it is completely backward compatible. So if you have a module, you want to make changes to it, the only changes you're allowed to make while keeping the name the same is to add things to it. You can't go remove. You can obsolete it. You can mark it as no longer used, but you really can't remove it. It's there. You sort of guidance on, you know, really don't need to implement it or you should not implement, but it's not gone. And if you want to make something that's not an incompatible change, you have to change the name of the module. But then we have all this great tooling support, but we don't have the tooling support to do the equivalent of what we have in our documents of update and obsolete. If we had that, we probably would be done. I know that's a confusing statement. We'll talk about it in NetMod. But that was the lack of that ability is the one problem that we had talked about during the formation of the design team that is not yet solved. We think that that is now come to the as a top issue in NetMod, that it's going to be worked there, that they're the right people to solve it. As long as there's a solution to it, we'll be good. So again, something that the design team doesn't really have to spend a lot of time on, other than just make sure it's going along. Well, is that enough to keep the design team around? Probably not. It is worthwhile to note that this issue's out there, and do we, as an area, want to have a position that may be different than what comes up organically in an ops area working group? We're throwing it out there, but to some degree, hoping the answer is no, we don't need to do something formal here. We can let that just run the normal process in NetMod. We've seen in the past that that doesn't always give us the right result. And sometimes we have to push a little bit to get different functionality. And schema mount's an example of that.
Sue Harris, in this case, IDR chair. BGP model has a non-NDMA revised data store model, and then a previous one from OpenConfig.
Sue, I'm having a little trouble hearing you. Just
I'm sorry.
in the room.
Am I not swallowing the mic far enough? Okay. Sue Hares, IDR co-chair in this case. So I'm facing some of the questions of data model revisions in IDR with the base BGP model. Did you have any, could you just review the current thinking from NetMod and provide a little insight on that? Thank you.
Sure. So why don't you stay there, because I'm going to probably end up asking you a question. The current guidance was first documented in the Yang 1.0 specification. It's repeated. I don't think with any really substantive changes in Yang 1.1. So if you want to look at what the guidance is about module updates, that's the right place to go look. And basically what it says is, if you make a change that is non-backward compatible, you have to change the module name. So you have to basically say it's a whole new module. That's what it currently says. Oh, and by the way, it identifies exactly what a non-backward compatible change would be. So it helps you understand what it means. That's what it says. The problem people are running into is that, let's say I do routing config-2. How do I know that routing config-2 replaces routing config- the original one, just routing config, RFC 8022 version? In our documents, we have a document header, which provides some metadata that says it obsoletes the old one. So we have that, that's good. But Yang models are designed to be consumed by computers, not by people. So the document header that's in an RFC doesn't do a whole lot. So we need something there. There's a couple of different there are a couple of different approaches to solving this problem that are being discussed. I'm more focused on, here's the problem. What the actual solution is, that's something that's going to be worked through the community. So there's a proposal out there to use revision numbering, sort of what you would see in software. There was another one on the list talking about just mapping what we did on the headers with updates and replaces. That's the actual solution. I don't know what that's going to be. The requirement is we need something that supports a tool-based approach, supports tooling, and supports computers figuring it out rather than people.
So that's
now, in terms of IDR, if you're talking about versions of drafts, that's not really envisioned in this part of compatibility between versions of internet drafts. That's not really part of this problem space, because that's viewed as sort of, those are working things. And you make a non-compatible change, that's okay, because that was just a work in progress. It wasn't a final thing.
No, I'm not considering the drafts. I'm not considering the draft case. I am considering the implementation case. So, thank you.
Leah Atlas. So, one of the pieces which relates to which is correlated to, but not the same as, how do we handle Yang module revisions, is how do we, as the routing area, continue to update and extend Yang modules, and what that management process looks like. And I don't think that piece has been really nailed down yet. We probably should be talking about it at breakfast on Wednesday a little bit, because that might come and inform some thoughts on what the module revision process, if there's any impact there.
Okay, what's breakfast on Wednesday?
Routing working group chairs.
Ah, right. Sorry.
Though we have other topics scheduled there, so it won't take the whole time.
Thanks.
Benoit Claes. So for the people who are interested, Lou, as a chair in NetMod, has got like maybe 35 minutes on this topic in NetMod. So if you're interested and if you want to get to a resolution, NetMod on Thursday is the right place.
Dejan Bogdanovic. So it would be very good if the routing working group could specify the use cases for what modeling should be done. instead of working on the actual models, work on the use cases and the workflows that have to be done. Because then we can come much faster to an agreement what has to be implemented, and then the implementation, can be done in a much more rapid way.
Benoit Claes, fine, but it's not a routing specific issue. This is like a Yang/industry issue.
So I think, so what I interpret from Diane is that we as a group have to make sure we inform NetMod of our requirements for handling revisions. So the fact that we're thinking about having a model that, or module that replaces another one, we should handle. That we have Sue's case, we should handle that. The mechanisms by which it is handled, I don't think belong in this working group. I think belongs over in NetMod. I think that's what Dan was saying. I hope that's consistent, Benoit, with you as from your AD perspective.
I think it is, but I'm wondering, okay, let's assume there is like a different area dealing with Yang modules, and hopefully we would have the same set of requirements. Otherwise, there is something which is broken somewhere.
Yeah, I agree, but I'm not sure that it's the scope of this working group to worry about the other areas' requirements. So I feel that I've gone through most of these updates already. There's a couple of important points, though, at the bottom of the slide. At the last meeting, we had talked about trying to make sure that the users of our NI model were going to be aligned and actually use the construct that we've come up with in this working group. So the first user we've looked at was in BESS, the L3 VPN Yang model. We worked with them at the last meeting and got good alignment on how that would be handled. And we talked about it a little bit in this working group and more inside BESS. What didn't happen was, and the L3 VPN model has been published and is well aligned with the NI model, and it in fact augments it exactly as we envisioned. So that's great. What didn't happen is we didn't do a similar process for the L2 VPN and eVPN documents. And again, these are documents in BESS. So we wanted to make sure to take the opportunity of this meeting to get that alignment. Turns out those authors didn't travel here. So instead, we met last week in just an informal conference call with some of the authors. It's not all of them, just some of them, to get the ball rolling. And we feel we've made good progress. There's still some confusion on how to use what we've defined. Like what goes inside NI type and what goes inside the root we mount. And we have some slides later if we end up having time that we can go through that again just to help get people to understand it. So we talked through these details. There wasn't a similar, the LNE doesn't have similar impact on BESS, so we didn't have a parallel conversation. Tags, I pretty much gave this update already. Chris is going to be presenting it in NetMod. If you're interested in it, come there, read the draft. So what are we doing next? So as a design team, one of the questions, what do we do with revisions? We've talked through that. At most, we'll try to document some requirements. I'm not sure there's anything unique to the area, as Benoit just said, although it would be good to talk with Sue and understand if IDR's requirements are a little different than what's already being talked about in NetMod. If it is, we'll try to coordinate how those requirements are brought in. The next thing, we really are focused on disbanding as a formal group, but that doesn't mean the work stops. We still have to make sure that the documents that we authored, contributed to, or tracking, that those have progressed through the process and get published as RFCs, but we can do that as individual authors. You'll see there's a good list there. So I think we've been busy. So the next, that's the design team update. we're now going to go into what that area that the chairs asked for, is to provide a little more background on how we're actually using things. So Dan is going to go through an example of an early implementation of LNEs. And just as a refresher to people, what's an LNE? It's a logical network element. It's a way of partitioning a system into partitioning its resources to be used by multiple logical systems, logical routers, VMs, whatever you want to call it, NFVs. But it's a way of managing what essentially are multiple independent routers living on the same physical device. Now, one of the interesting things is we actually made sure that the model was recursive. So you can have some bare metal, you partition it up and put a bunch of routers on it, and then those routers can partition themselves up as many times as they want into logical routers. That's the LNE part. That's what we're going to go through. Just as for context, NI, that's all about VRFs and VSIs. What's a big difference there is sort of the management structure. With a virtual router, logical system, you always do full partitioning. With a VRF and VSI, that's always managed within a single context. Dan, you can start coming up wherever you are. Hopefully you're still in the room. So the module tree for LNI is what you see here. We do have the ability to do sort of top-down management in those cases where a system supports that. And that's what the, I think we have a pointer here. Here we go. That's what the root is all about, the LNE root. But that's only accessible when managed equals true. If you were building, let's say, NFV style routers where they're running in VMs, you would just set it to false because you wouldn't be able to manage it from the top. And that's going to be a pretty common use case. We also have some error events to deal with late binding problems. I'm going to turn over to Dan, talk about his implementation.
Pay attention, it's not a theoretical work, it's a real implementation that's working. Go ahead.
Hi, Dan Bogdanovic. So this is the work that Raymond and I did, and we'll share some of the experiences and some of the problems you might be facing if you try to implement this. So this is the example we are covering essentially where you have an LNE spanning on two physical devices, as well when you are doing an LNE on another physical device. Some of the problems that you will run into that will be, with the interface naming, especially when you are trying to do it over two physical devices, and as well how you will do the IP management addresses. So when we decided how to add interfaces to an LNE, when we implemented, we did it pre-standard times. And we were using groupings in order to essentially be able to add interfaces to the LNEs. And in that case, the physical device manager cannot manage the interfaces. Once they're assigned to an LNE, they cannot be managed outside of the, outside of the scope of the, essentially in this case is the virtual router. So with interface naming, when you're defining that, you have to come up with a pretty good schema how you want to name them, because you can have an interface on a device 1 and an interface on a device 2, they have exactly the same name. And the question is now, how will you name those interfaces when they will be essentially bound to your virtual router 1 and virtual router 2, which are the two instances of an LNE. And essentially, you can have now two ways in the schema that you just use the physical device name with interface name. And for that one, so we were thinking between both options, but we went with an option that doesn't require changes in Yang. So in this case, it is pretty easy to find out which physical interface is on which physical device. But the whole point here is that you also have to figure out how you can take the multiple leaf refs in order to get to the new value, because it's the whole point there is, well, how can I combine the physical device ID with the ports. On the other part, when you are having essentially one LNE across multiple physical elements, there is a question if you want to have capabilities like an aggregated Ethernet interface. And the questions are rising when you have different capabilities of a data plane. So how do you want to support that when your capabilities and the resources of a data plane are not heterogeneous, or you will just go essentially with the same types of ASICs, then you can easily track the capabilities and resources. So this is something that you have to think up front how you want to do that, because it is not just enough to track the capabilities, because the capabilities and resources, if you're not tracking the resources while tracking the capabilities, you can come up into resource management issues, and that you will not be able to create some of the services across multiple hardware units. And also one of the other issues is how you will create out-of-band IP management, network management of the LNEs. So you might have on the same device running multiple SNMP daemons. So how will you make sure that all of them can use the same SNMP port and that you will be able to differentiate and make sure that is correct binding? There are a couple of ways, how you can do that. What we decided was that we will have essentially an IP pool manager, and that IP pool manager would be essentially assigning the IP addresses during the orchestration time to each LNE, and then it would be essentially providing the outside connectivity to the NMS system, to the LNEs. We were thinking maybe dynamic net might do the work as well, but for some reason we have decided to go with setting up here's a specified pool of addresses. You have to know how many LNEs you have to address up front, and then essentially take it from there. From a performance and scaling point of view, this works pretty well for us, so we had a pretty good experience with this one. How we did it essentially is that we had essentially a public IP pools, and we were essentially saying how many nodes, there's one IP per node, and then which services are you mapping to that, and then which ports are mapped to those services. Essentially, that would be it. So these are slides from the previous ones, but actually, I'm curious from the operators, how many of you are thinking about having essentially, actually, how many of you are using logical systems or logical routers on your existing physical devices today? Well, I mean, a few hands. And are you using, well, so next one would be, and for the verbs. And then I would be really curious to hear what is the main use case for your logical, router, logical system.
Rick Taylor, I'll give you an answer at the mic to why we're using LNEs, and it's to reduce complexity. The hardware is getting increasingly complex, and it means that the end users who are actually having to use this kit, it becomes much simpler to talk about logical constructions, and then they don't really care about which model they bought and how many internal backplanes and stuff. It's in there. So it's really ease of use. We found some real advantage to going down the LNE model.
Stefan Kowski from Orange. I mostly agree with what has been said here. we are not using logical system now because we don't have the exact separation that we want. So especially on some specific routers that are supporting logical system today, we are only separating the routing part, but not the management and all the other processes. But we are looking for this kind of full separation, including all the processes within a router. So we are doing some testing on new features today because, yes, we want to reduce the complexity of our routers because running a lot of services, MVPN, layer 2 VPN, layer 3 VPN, on the same device is really complex today. And it's not really maintainable over time. So we need to split. So it's clearly interesting. It's not doable now. It may be doable in future.
So it seems like in your case, it simplifies the config management among different services.
It's not only a question of configuration management. It's just a question on when you have a router running tons of features, it does not work because there is a lot of bugs, and one bug on one particular service will prevent you to install a version. How to say that? Yeah, let's say that I have a router running MVPN, layer 2 VPN, layer 3 VPN, internet services, and you want to upgrade this node. You may fall into a situation where you are not able to upgrade it because you are not able to find a version which is bug-free for all the services at the same time.
Yeah, yeah, okay. So, sorry. You want to take this over? No, go ahead. I haven't been.
Dean, thank you for sharing your implementation. And
So,
more comments are always welcome.
again, at the request of the chairs, we brought back some material that has been presented at previous IETFs. We're happy to go through this at the level that makes sense for the room. If what we're saying, people feel like, well, we've done it already, I don't need to say it again, so we can get some time back for an early lunch, or we can spend the rest of the time going through these few slides. It's really the chair's call, your call. So what that means is ask questions. And if I'm just talking to a quiet room, everyone just typing away and no one's really interested, we should stop. But it's your call. Go ahead. So most of these slides are taken from that discussion that took place at the last meeting in the L3 VPN context in the BEST working group. There are one or two other slides at the very end, which from other meetings. So generally, when we're talking about how do we do VPN support, we want to look at our logical network element model. Loud behind me. So you can find that in draft IETF routing network instance model. The version here is wrong because this is from the last IETF. There's a new version on it. But there's not anything really major change. There's a couple of syntax changes, but those aren't material for understanding what we're doing. The key thing that we're doing is we're creating a list to represent each VRF or VSI. And so every layer 3 VPN, layer 2 VPN, we call that generically a network instance. We also recognize that some instances are bridge router instances, so they do both layer 2 and layer 3, and we cover that case as well. When looking at how to model a VPN, we have some set of information that ends up, actually most of the information for controlling that VPN ends up inside the core instance. Really think about it as it belongs to the PE alone. It doesn't have any information that ends up getting communicated to a CE. So think of that as your RTs, your RDs, some of your label management policies. Those types of things really belong to the PE. Where do those go? What we have is we created a place to hold that type of information, but we ourselves didn't instantiate that. We think that belongs to the VPN specific technology. So what we do is we have a place for augmentation called NI type, network instance type. That's where the PE information is that's related to a network instance. For the information that belongs to the CE, most of the time, what goes there? There's some information that is routing protocol specific or control plane specific, and those what we have to represent is actually really just an existing model, or 98% is just existing information. For example, if we want to run BGP between this as our CE PE protocol, we need a whole BGP model, and we need a place to put it. If we're running, let's say, an L2 VPN and we want to instantiate, I don't know, some IEEE model that supports the CE to PE communication, we need a place to instantiate that. And we place that underneath our different types of routes. So here we have CE information, here we have PE information. I think I have a little more details on that. So we had talked about at the last meeting likely impact. This is now actual impact on L3 VPN and likely impact on L2 VPN and eVPN. So what's the NI type for L3 VPN? Well, it's just a new container which augments the NI type and has all the information that is specific to configuration of an L3 VPN. If you're interested in what that actually looks like, we can actually bring up individually, I'm not going to do it here, can bring up the draft that's now published as draft IETF best L3 VPN Yang, and I don't remember if it's Yang model or just Yang. It's just Yang. And you'll see that draft actually does that. So we have all the PE information sitting here. And then within the context of the L3 VPN, we just mount a new instance or per NI instance of existing models. The same thing, the same models that you would see for the core, but now you have data that's instantiated just for that specific VPN. And there's no modification there to those models at all. In the rare case that you actually have a modification, and we haven't figured out one of those yet, by the way, we keep thinking we're going to have them, and then we don't. We go through the details. But if you do, you could just, you can just augment the model that you have as you need, and instantiate it only for the L3 VPN. What does that all mean? That sounds a little confusing. I think I have. Nope. So models, when you code the actual model, you represent, as a vendor or as an implementer, you represent what models you support through a couple of mechanisms in Yang. At the top level, the most important mechanism is something called the Yang library. Basically, a device, a router, can expose to a network manager, to the client, the list of all the modules it supports, and that includes all the augmentations. And it does that at the top level as a library. And that describes what the schema looks like. Inside a network instance, you have the same thing, but instead of talking about at the top level, you want to talk about at a particular mount point. So in this case, the mount point is called VRF root. And we need a way of doing that, because a new way of doing it, because Lang library doesn't have it. The mechanism that we're using is something now called schema mount. So in schema mount, you can identify a mount point. The way you do it is you identify the model. Well, the model's missing here, but we have our model name, which is the network instance name, and then the mount point within it, called VRF root, and then you list exactly the same information you would list for the top level in that Yang library. In fact, Yang library defines a grouping, and schema mount just reuses that same grouping. So you describe on the router, describes exactly what's going to show up here. So it's an implementation time decision how you're going to, or how a router is going to represent its VRFs or VSIs to the clients, to the network manager. So most of what we're talking about here is a framework for implementation and giving implementers, vendors, the tools they need to go represent the logical partitioning of the system, the VRFs, in a way that is consistent for operators or vendors of network management software to go use. I've talked so far about where PE information goes, that's per network instance. I've also talked about where CEPE information lives. There's actually a third class of information, which is because you are a core router, there are some system-wide configuration parameters that are specific to the fact that you run VPNs. Where does that go? Doesn't make sense to put it anywhere on this page because this is per instance. It's per VRF. But what I'm talking about here is a third class of information that is box-wide. Where would that go? It actually doesn't belong in our model. It belongs in either an augmentation to an existing protocol such as BGP, or in the case of like pseudo-wires, it's actually a new model completely. And that's what we're going to see. We don't have that case for L3 VPN, it turns out, but we are going to have that case for L2 VPN. And so that's some of the discussions that are going on of what you'll see, hopefully, in the next rev of the BEST document, the L2 VPN and EVPN drafts. Again, we've talked to some set of the authors, the ones who are not here. There's at least one author who I don't see in the room of those documents that we were hoping to sync up a little bit more. I have two slides on LNE. This is the model that Dan was talking about. The difference between what I'm showing here and what Dan showed is Dan actually built a early implementation based on our work. This is theoretical. So, this is sort of more generic. It's more applicable to anyone. His is an actual example. Which one is more applicable to you may be whether or not, depend on whether or not Dan's example is close to your example or not. If what Dan talked about didn't resonate with you, then this might. So in the LNE, all we're really about is providing a construct for partitioning resources. In this case, it's not tables, but it's actual resources, and distributing those resources to multiple logical systems. Now, these may be implemented sort of how router vendors have traditionally done logical systems, or it could be VMs, or it could be containers, or it could be any way that you partition your system. We think that there's multiple pieces that are going to be important. Like, for example, if you had QoS resources, we think that's going to be an important thing to partition. But we don't have any really good standard models that identify resources today inside the IETF other than interfaces. So the only thing that we worry about partitioning at the moment is interfaces. So we have the ability of taking an interface and basically assigning it to a logical network element. We do that through an augmentation that was on the previous slide. The other thing we think is important to be able to support is the ability to support different management models that we have in logical systems. In a VRF-based approach, a VM-based approach, typically there's no way for, let's say, the hypervisor or the host to manage what's going on inside the VM. There's no visibility across there. So we represent that with the manage flag being set to false. In a more traditional router-based system, the top level, the core router, core instance, actually can look in and change things that belong to the logical system. We support that as well. We support it using two items. You set manage equals true, and then you have a root mount point. And that root mount point, like we talked about in the NE case, that root mount point can be can include any of the modules that the vendor wants to expose underneath that root. So it allows top-level management down. So what we have here is an example of a core, think of it as the metal device, the base device. It's got some hardware, it's got some interfaces, and it's got a list of logical network elements. In this case, we've instantiated three logical network elements, the blue logical network element, the red logical network element, and the green one. Inside, from the top level, you can actually, in the manage true equals case, you can see all the information, the full list on the left side of the page. So if you're coming into the core manager, you can see everything. But if you're within the instance, let's say I'm inside the red, I'm customer red, and I come into the network management interface in the red space through an interface that belongs to red. This is the management channel that Dan was talking about earlier. You wouldn't see everything, but only the pieces that belong to red. And likewise, if I was customer green, I'd only get to see green's information. So we would start out from a top level where you have a system that has a full set of resources, an understanding of a full set of resources, and also a full set of all the parameters. And then we have customer-specific views that are coming in through the system management protocols and interfaces that are configured for that customer. That's all I brought. So hopefully that was helpful. There's definitely some subtlety here. There's a lot of, it's a new way of representing something that we've done for a long time. So we have to help each other map our old way of doing things into this new network management framework that Yang provides. Thank you.
So I would like to thank you, Routing Young Design team, for taking time and effort and helping everybody to better understand. If you've got any questions, and especially those of you who are going through implementations, and you could provide feedback, what's working, what's not working, I think it would be extremely useful to know. And I'll have few requests to design team for the next IETF meeting, probably talk about interaction with service models. So
well, our hope is there isn't a design team at the next meeting, so we'll figure out.
You know who you are, right?
Okay. One thing I forgot to mention is we have talked to a few people who are doing implementations of both LNEs and NIs. By the way, you don't have to do both. You can choose which one is appropriate for a platform. And we've talked to more people who are doing NIs. And it definitely is, the first few implementations are going to be, I think, a learning process. But once we have a couple of implementations in the marketplace, I think it'll be much easier for the next set of implementers to figure out how to do it.
Yeah, perhaps if there are more implementations, would be worth setting wiki page and describe what's been done, what's working, what's not. So, you know.
Yeah, as we know, vendors are always a little cautious about what they put up there, though. So. Now, the individuals of the design team are willing to talk to you. So if you have questions, please just contact us. And you can contact the whole design team or individuals as you see fit. Thanks again.
Thank you very much. We are wrapping up Monday meeting, and we'll see you on Thursday. So you are going to be, right? Who's going to be in the blue sheet? Thank you.
did it.